Okay, looks like it's time to get started. First of all, welcome everybody. I really appreciate you showing up this evening. I know it's a little tough at 5 o'clock midweek. My name's John Messick, and this is my colleague John Patterson. We're program managers on Virtual Machine Manager. And today we're going to be talking about managing and securing the fabric with VMM. Got some new folks coming in the door late. Already asked the rest of the group, but if you get a chance, please pick up one of the surveys that are scattered about and fill it out for us if you would. That would be really awesome. We're working really hard to collect data from you guys to understand our customers a little bit better. Okay, so what are we doing this evening? We're going to spend a couple minutes talking about what the product team has been doing in the past year to change the way that we're working on VMM and figuring out what we want to build for you guys. We're going to talk about what we have in market today, and then finally we're going to look ahead at what we're building for the next release. Now, the first two bullet items we're not going to spend too much time on. There's a breakout session tomorrow morning at 9 a.m. Really be great if you guys could show up to that as well, and they'll dig into a lot more detail on those the first two bullets. And then finally we'll end with a Q&A at the end. Okay, so what are we doing? New way of building our product. We've really changed the focus in the product team to really focus on what you guys need both today and in the near future, and that's really about gathering data. So a lot of this pivot that we've made is really gathering backing evidence to understand what we need to build and validate with you guys in a much faster cadence than we have in the past. And that's through things like surveys that you see sitting out here, calls, conferences. I'm sure we've already worked with a bunch of you guys in a lot of our calls. And then also tools like User Voice. I don't know if any of you have seen it yet, but if you would like to, go out to systemcentervmm.uservoice.com. That'll provide you a way to give quick feedback directly to the product team. We look at this site almost on a daily basis, definitely review it every week. We look at the top voted items on it and see what we can do about it. And we've actually had a lot of features come out already that we probably wouldn't have addressed if it hadn't been for the fact that you guys have come in and given them votes on User Voice. We're also doing social media. We're on Twitter. We've got a bunch of blogs out. Go check that out. The idea here is that the data flow is both ways. We're getting data back from you guys, but we're also pushing it out in a fast cadence so that you can correct us if we're going in the wrong direction or if we're not building what you guys think we should build. So check us out. We're also working on delivering value to you guys at a much faster cadence. We've kind of settled on this 3-month UR shipping cycle, and we plan on continuing that in the future. So, you can look forward to 4 updates a year. And we've also expanded what we're building in our update releases. So we're not just doing bug fixes anymore. We're starting to ship new features. So you don't have to wait 18, 24 months till we ship the next major version of VMM before you can start getting those new features that you're asking for. So what's in market today? We just released UR6 in the past week. Point of example, Generation 2 VMs and service templates. This is one of the top items on User Voice. It's not something we probably would have addressed at this point if you guys hadn't voted it in. It's there now. Go download UR6. You get Generation 2 VMs and service templates. Also a lot of other new features. Overcommit for replicas. I believe that came from User Voice as well?
I think we got that from survey.
From survey, okay. Definitely from this data flow for sure. Azure View, a lot of cool stuff coming down the pipeline. We've also been obviously fixing a lot of bug fixes. We've done some performance and usability improvements. We've got quicker VM deletion, a lot of stuff coming down the pipeline, and we're trying to deliver it to you a lot faster than we have in the past. Install latest URs, you get it. All right. So that's all we're going to cover for what's happening in the past and how the product team has changed. Again, go to the breakout session tomorrow and you can get a lot more detail on that. So what's coming next? First thing we're going to talk about is assurance. There's been a couple of breakout sessions over the last week on assurance, not VMM specific, just in general. Have any of you guys been to any of those or heard anything about it? Okay, well, cool. It's almost 0. So this is about running secure workloads. In particular, this is addressing the idea that hey, what is one of the major problems people have today with doing things like moving to the public cloud? Obviously, there's a lot of workloads that people are already moving, but then there's also a lot of security concerns. We're hearing on a weekly basis almost about major security breaches all over the place, and that's keeping people from virtualizing a lot of their workloads and then moving on them into either hybrid or public clouds. So this assurance effort that Microsoft's working on is specifically trying to address that. And how are we addressing it? Shielded virtual machines is the main focus of what we're talking about today. Now, what's a shielded virtual machine? My colleague here put it very succinctly. It basically means a virtual machine that if somebody runs off with it and steals it, copies it off your drive, whatever, they're not going to be able to do anything with it. It's going to be secure from encroachment by somebody who steals it, even from local administrators on Hyper-V or any of the other administrators you may have in your environment. And your data is protected. The internal state of your VMs are protected at rest while it's on disk, while it's in memory, while it's being run on Hyper-V hosts, as well as while it's being transferred over the wire, so it's encrypted over the wire. And we'll go into details about how this is managed. So what's the value of shielded VM? Should be pretty obvious. You know, when we break down our customers, we're looking at kind of three major segments: enterprises, hosters, and tenants. They have a lot of the same concerns. You put something in a virtual machine, there's a huge surface area of people who can get to that data, who can manipulate it, who can steal information from it. It's keeping people from moving to public cloud because there are regulatory and security requirements. A lot of good reasons why you want these things. So there's two major focuses that we're looking at in VMM around assurance. And the first one is all around managing and creating virtual machines, which I'm going to talk about over the next 15 to 20 minutes. And then the second piece is managing the guarded fabric, which John's going to talk about afterwards. So when we talk about managing shielded VMs, the bulk of what's interesting is really about creating them. That's where a lot of the differences you'll see happen from a self-service user's perspective or from a tenant's perspective. Now, I'll go into more detail in a few minutes about exactly how and what a shielded VM is, but basically we are going to expose three different ways that you can create these things. The first one is we're introducing a new VM template type, which is a shielded VM template. This is going to be your most secure option for creating shielded virtual machines. And the reason it's most secure is twofold. One, the source material, in other words, the VHDs that your VMs are created from, can be verified before you create your VM and during creation. And the second one is that after the creation of the shielded VM, if you're deploying a Windows VM, you're going to have guest BitLockering enabled by default after your shielded VM is created. So there's really, from soup to nuts, there's hopefully no way that somebody can taint that data or manipulate your VM in a way that leaks secrets. But we understand that there are a lot of existing workloads that are not ready to be moved over to a new VM model. So we're also going to allow you to take your existing Generation 2 VMs and shield them. So it's as simple in VMM as selecting the VM, providing some encryption information, which we'll go over in a little bit, and clicking a button, and bam, you've got a shielded VM. Now, this is not near secure, because if you had a compromised VM before you shielded it, it's still going to be compromised even though it's shielded, because maybe there's malware on it already. There's nothing we can do to understand the provenance of the material that was used to create that VM. And the second thing is that since this is an existing VM with an existing workload in it, we're not going to go in and enable BitLocker in the guest by default. So even though it's shielded, and I'll explain again more in a little bit what it means to be shielded technically, your disks aren't encrypted with BitLocker, so they're still sitting in plain text on your hard drive. And finally, there's shield on create. So this is more or less the same value as shielding an existing VM, but it's done when you're provisioning a VM from an existing VM template. So we know a lot of people have a lot of investment in existing VM templates, and maybe they're not ready to move over to shielded VMs quite yet. So what are the components that we need to create shielded VMs from VMM's perspective? First one is the shielded disk image. So when you create a new VM, typically in VMM, you're creating it from an existing VHD that's sitting in VMM library. Now, that VHD is subject to being polluted by any number of people. You know, your storage admins could touch it, your VMM admins could touch it. There's a lot of fingers on those VHDs, and so you don't really have any assurance that that disk is what it says it is. It may be pre-populated with some nasty business in it. So we've introduced this concept of a disk catalog. And at its core, what a disk catalog is simply a cryptographic hash that's signed, that's associated with that VHDX. So it's a hash of the contents of the VHDX. Now, this is created by somebody that you implicitly trust. And again, in a few minutes, we'll talk about who you should consider a trusted entity. And it's also got some other metadata information, such as versioning, that helps manage these if you incrementally change the content of the VHDs. Second piece is a shielded VM template. I already talked about that in the previous slide. Much like our VM templates today, except that, of course, they have to reference a shielded disk image because we are not going to allow you to create a full shielded VM from an unknown source. Oop, not quite ready there yet. And the provisioning workflows are slightly different because in today's world, when you provision a new VM, you're doing things like providing the administrator password through VMM for provisioning of that VM and other things like domain join information. In this new world, you don't do that, and we'll talk about how that works. So the final piece is this thing called a provisioning key file, which you'll also see referred to as PDK. And this is a file that's authored by somebody who wants to create a shielded virtual machine. So creating a shielded virtual machine isn't as easy as it was in the past, where you just go into a portal or the console and type in a little bit of information, and provision the VM. Now you got to do a little bit of extra authoring because, you know, we're trying to secure your data and it doesn't come quite for free. So there's this thing called a provisioning key file. And it's created with a tool that anybody can download and author these things. And it's got a little bit of information in it. One, customization data for the guest. So in today's builds, this is an answer file, an attend.xml. And it can also contain other files like RDP certificates, provisioning scripts, anything else that you want injected into your VM at customization time. It's also got this thing called a list of owners and guardians. And an owner is somebody who can modify a provisioning key file, and a guardian is somebody who can't modify it, but they can decrypt it and look at the information within it. So the idea here is that somebody, let's call them tenants, somebody who wants to create a VM, a tenant, will create one of these provisioning key files, set themselves as the owners, or maybe somebody else that they trust, and that way they can go in and modify this provisioning key file. But then they're going to set their hoster as a guardian so that the hoster can decrypt it and look at that information and create VMs on their behalf, but they can't modify and do nasty stuff within this provisioning key file. And this group, this owners and guardians, is also called a key protector, and there's a little bit more information around that, but that's the gist of what it does. And this key protector is not only used to protect the provisioning key file, but when a shielded VM is created, it's also used to protect the virtual TPM, which we'll get to in a minute, of the shielded VM as well. And the final thing we need to have in this provisioning key file is a list of trusted disks. So you don't want to be able to have somebody take this provisioning key file and use it on to create arbitrary VMs of disks from disks that maybe you don't know what's in it. It's got some stuff that can leak secrets for you. So you can specify a list of, I'm only going to allow this set of disks to be used as source material for my VMs. There we go. All right, so before we get into too many more details, I'm going to give you a quick demo of what this looks like from a tenant perspective. And in particular, we're going to go through the WAP portal and see what shielded VM provisioning looks like. So I'm going to, And by the way, this is pre-recorded because we didn't want to mess with any VPN or RDP issues. So what I'm doing here is going into the WAP portal. And for those of you who aren't familiar with WAP, WAP talks to SPF, which is another product, which talks to VMM. So all these VMs you can create in the WAP tenant portal are ultimately residing in VMM clouds. So as you can see here, we've got our set of VMs, existing VMs, and we've got a new column here, shielded. So very straightforward. We're trying to make this as simple as possible. In this case, you've got somebody has gone in and created 2 shielded and 1 unshielded VMs. Here's a list of those PDKs or provisioning key files that can be used to create new VMs. And these PDKs are stored in VMM. VMM can't read them; they're encrypted, and VMM doesn't have any access to read them. But they're stored there for ease of use in creating new VMs. And this provides you the full functionality of adding new PDKs, deleting them, etc. And you can see there's some metadata information here about owners and guardians. And you can have multiple guardians, and this is really neat for instances where you want to, for instance, say, okay, I'm going to let hoster A run my VM, so I'm going to set them as a guardian, but I also want to allow a recovery site to also run it, and they may have a different guardian public key, which can also be injected in it. So now you're allowing 2 different entities to run your VM. So to create these, there's a couple of pieces of information that you need to have access to. One is the guardian key, which ends up being in the list of guardians. And there's only 1 per VMM instance, so it's pretty easy to download here. So this is a little bit of extra effort that a VM author is going to have to do. So they'll go in and create a guardian, or download the guardian key from their hoster. And then the other thing is they need to be able to download the disk catalog. So this goes back to when you author your provisioning key file, you want to specify which disk set can be used with. We got a little snag here. Sorry, I think our video paused. Hold on a second. Hey, John, can you help me out here? I don't want to restart the video. Oh, there we go. Okay, so they can download the catalogs from here as well. And although the catalogs are technically associated with disks, from the WAP portal they have an abstraction where it's associated with VM templates, which are in turn associated with disks, because you can't create a shielded VM directly from disk through the portal. So this just makes it a little easier from the user's perspective to download the information that they need for authoring these things. So now I'm going to go in and create a new shielded VM from the standalone virtual machine / gallery. And I don't know how many of you are familiar with WAP, but there's a catalog of both disks and templates that can be used to create VMs. In this case, we only want to look at templates, so we're going to filter just on templates. And for those familiar with WAP, you've only ever seen the second of these types of templates here, which is just your standard VM template. It's got a little bit of metadata on the right. Nothing real surprising there. But the second one over here with the nice little shielded icon, that's our shielded VM template. And it's got the same sort of metadata over on the right, but it's also got some additional information. You know, yes, it's shielded. It's got disk ID information around it to help you with authoring those PDK files. So I'm going to select this one. Actually, I'm going to select the unshielded one first and show you. As you can see here, you're putting in secrets. This is not very cool. There's lots of people between your browser and the ultimate VM where this data can be leaked. But that's the way we have been doing it forever. However, if we go back and we select the shielded VM template, you'll notice there's no secrets that are being passed directly. Instead, the only thing you're passing is this encrypted PDK file, which only a very few people, which you explicitly set to, can decrypt. And then your secrets are contained within that, and that's all you specify to create these new virtual machines. Okay. So VM provisioning workflow. Let's talk a little bit more about how this works technically. So on the right-hand side here, we've got our fabric, and it's a very simplified version of the fabric. We've got a VMM server, and we've got a single guarded host. There's actually a lot of guarded fabric behind this that John's going to delve into in a few minutes. But for our purposes, this is all we need to talk about. So what happens? A user decides they want to provision a shielded VM. Among other things, they are providing the PDK, the key file we talked about, and they're also providing some non-secure data, or data that we at this point don't consider secure, things like the machine name. So that gets passed to VMM, and a request is made to create a VM. So VMM calls in and creates a VM on the host. The key protector, remember that's that list of owners and guardians, that's extracted from the key file. Now this is something that VMM can extract. It's not a security leak. There's nothing we can do with it, and we can't use it to decrypt the key file, but it is basically an access list of people who can do things to whatever it's attached to. So VMM detaches that, or extracts that from the key file, and then passes it to, or applies it to the VM, and then enables the TPM on that VM. And so at this point, we've got a virtual machine with a virtual TPM attached to it with a set of protectors that encrypt it, or that determine who can decrypt it. Finally, the provisioning data, and this is stuff that's going to go into the guest OS. This is, remember back, this is things like your unattend.xml, any other certs you have, as well as the non-secure data. That's all taken together and passed to this provisioning service that's run in a highly secure mode on the Hyper-V host. Now, this data at this point can't even be accessed by a full admin on the Hyper-V host. Even if they've got a debugger attached to this, they're not going to be able to get to it. It'll never be able to be decrypted if they've got a debugger attached. So what happens is this secure provisioning service rolls the VM BitLocker key. So I forgot to mention that as a part of shielding these source VHDs, BitLocker is also enabled on them. However, when we're creating an instance, we want to roll the BitLocker keys because otherwise every VM we created from a particular template would have the same BitLocker key, and that would be a fairly large security hole. So the provisioning service rolls the BitLocker key, decrypts the key file, prepares an unattend file, injects that all into the guest file system. And then at that point, we have a real and true shielded VM that's got everything encrypted. It's got guest encryption. The TPM's encrypted. There's only a very small set of entities that can decrypt it. And then guest OS customization completes. So I'm going to show how this works within VMM. So I'm going to open the VMM console. And just real quick, I'm going to navigate to our list of VMs view. Very much like WAP, we've got more data showing that, yes, this is a shielded VM, or no, it's not. So we have kind of full native support for this now. Now I'm going to move over to the library, because this is where more of the artifacts exist. Now, if we look at VM templates, again, just like in the WAP portal, we've got shielded and unshielded VM templates. You can look at the properties on these and get the information about it. So there's a couple of interesting differences between shielded and unshielded VMs. In particular, if we look at the firmware, shielded VMs or VMs with TPM have to have secure boot enabled. So you can see here that it's enabled and the checkbox grayed out. You can't change that. But then there's also this new piece here called Secure Boot Template. And it defaults to Microsoft Windows. And this allows secure boot with Windows operating systems for the guest. However, we're moving forward, we're also supporting Linux, and that's going to require a different secure boot template. So if you look down in the drop-down list, We've got UFI Certificate Authority as well as the Microsoft Windows Authority, and depending on whether you're provisioning Linux or you're provisioning Windows Guest, you'll select the correct one. And that list is kind of dynamic, and it may change in the future. And I should also mention that the initial releases of this assurance work is not going to have provisioning support for Linux, so that's going to be a little bit down the road. So the next thing I want to do is create a VM template, a shielded VM template. So again, just like everywhere else, we can see which of our artifacts are shielded and unshielded. In this case, we've got one shielded VHDX, which a trusted entity has gone and cryptographically signed and put that metadata on. So first I'm going to start creating a VM template with an unshielded disk. And as you can see, this has been here for a while. It's got the generation option, nothing new here. However, if we select a shielded disk as our source material, VMM is aware of that, and it's going to change fairly significantly the way you author your VM template. So if we go through it, you'll see that now there's no longer any option for Gen 1 or Gen 2 because shielded VMs have to be Generation 2. And there's a few less options for things like configuring the operating system and so forth. So next thing I'm going to do is create an instance of a shielded VM. So as we go through it, this is a little slow. This was recorded on a dev cluster, so not the most performant thing. And we can see here that obviously we're not putting in passwords or anything. The only thing that we'll be providing instead is the shielding data, which you can upload here, or which you can select here, and this is stored in the VMM library. So we select the shielding data, and that's going to contain all our customization information. Now I want to do one last thing here, which is show placement. So hosts have to be configured properly to be able to run shielded VMs. It's not just like you can take this VM and throw it on any Hyper-V host and it'll run. So as we run our star rating, we see that some Hyper-V hosts can run this and some can't. And if we look at why there's 0 stars on some of these, it's because the host is currently not guarded in the host guardian service. Shielded VMs can't run on this until it's in a guarded state. So across the whole provisioning process of shielded VMs, VMM is aware of what needs to be done and which entities are able to interact with which one across this. And the final thing I wanted to show you was if you create an unshielded VM, obviously I mentioned this earlier, we've got the ability to shield this VM after it's created. And this is from a standard template, so every template you have now will automatically have this option so it can be turned into a shielded VM when it's created. But you don't get those security assurances that you do with a full shielded template. So I just wanted to real quick show you a little bit of our API. What I'm doing here is getting the set of hard disks in the VMM library and then looking at them so we can see which ones are shielded. And first one's shielded, so I'm going to call this new API. Get SC volume signature catalog, and I'm going to pass it that shielded VM, and that'll extract that catalog metadata for that disk. And this is what WAP uses. They call into, well, SPF technically calls into us to get this information. So any up-level portals you have can call into this API to get that information and manipulate it in whatever way they need to. And at this point, I'm going to pass over to my colleague John, and he's going to talk to you about guarded hosts.
Thanks, John. So yeah, we're going to talk a little bit about guarded hosts for something like 15 minutes. Then we're going to move on to, hopefully you can hear me, to upgrading your clusters. So that's kind of what I'm going to spend some time talking about. And we're going to go with guarded hosts. And if we remember all of John's secure VM, shielded VM stuff, the motivation was actually pretty simple, right? Eventually, we assume you're going to end up losing your VM. Someone can take it at any point in time. What we want to make sure of is when that happens, because it's going to happen, that it's useless. So what's the opposite side of that, right? The opposite side is whatever host that we want to be very prescriptive about what host can actually run the shielded VM. We don't want any host in the universe to run it, otherwise it's useful even when it gets leaked. So what we're going to talk about is what a guarded host is. And a guarded host is exactly that. It's whatever host can run a shielded VM. And it gets it by getting a key that can unencrypt the VM. But in general sense, it can run the encrypted VM, right? And there's a couple basic questions you might ask, like, well, who decides if a guarded host gets to run the VM? The host can't decide. Wouldn't make any sense whatsoever, because then your intern hooks a laptop into the network, is running your domain controller on the laptop, and there's no security there. So the host can't do it. So what ends up happening is we have a host attestation service. Here we go, yeah. Attestation service, we're going to talk about it. And the attestation service makes the decision of, OK, can I give you the key to run this VM or not? Additionally, we may ask, well, who owns the key that unlocks the VM to begin with? And that's a key protection service. We're going to have a little less about that. But it protects the key that the host can use. OK, so how does this work? In a very simple kind of diagram, a shielded VM sits on top of a VM host that is configured to run shielded VMs. And it reaches out to a host guardian service and says, hey, can I please get a key? And it hopes that the host guardian service says, yeah, you can. And there's been a great presentation by Dean Wells, I believe it was yesterday, on how the host guardian service is set up. As Fabric administrators, typically we think about this as outside of our scope. But we still should know a little bit of how it works, just so we know what we're messing around with. So the host guardian service is really split up into two different services, the attestation service and the key protection service. So to put this in kind of a friendly version, sort of like the slide before, may I play as a key, what really happens is the host says to the attestation service, which decides, hey, can you run the shielded VM, says, mother, do I have permission to run the shielded VM? Here's who I am. The mother recognizes and says, yeah, you can. Then it reaches the key protection service and says, hey, mom gave me permission. Dad, please let me have the key. So that's sort of what happens. Now, when we're configuring our guarded host, from this slide, you can kind of see we need two things to be configured on the host anytime we want to run a shielded VM, anytime we want to set up a guarded host. We need a URL. It's really these two arrow lines. We need a URL pointing to the attestation service. And we need a second URL pointing to the key protection service. So anytime you're doing a guarded host, think, well, we're going to need these two. So at a minimum, we need these two. So now let's talk a little more about, in fact, let's make a big generalization. I liked writing this slide. We're going to concern ourselves mostly with the attestation service, because in configuring the host, that's what this all hangs on, is whether or not the host is viewed by the attestation service as cool to run my VM. The key protection service is super important for the VMs, because without the key, if there's any issue there, the VM won't get unlocked. But we're going to worry mostly about the attestation service at this point. So here's the question. I'm a host. I reach out to the attestation service. How does the attestation service say, hey, you're OK to run the VM or not? Let's go with the easy mode first. It's called Active Directory attestation. And so in this case, the attestation service says basically, hey, not every host in the world, maybe not every host in my data center can run this VM, but any host in this particular AD group can. So you've already restricted the entire world down to a set of hosts that the attestation service trusts. So this just removed the ability for your intern to plug in a laptop into your switch, add it to VMM, and start running secure workloads. We've narrowed it down. The other benefit of this is it's really, really easy to set up. Your current hardware is going to work fine, because all you have to do is add it to an AD security group. And if we really think about it, what information do we have to configure on the host to get this to work? We need the attestation URL and the key protection URL. And really, that's it. Whether or not it's a member of a group isn't really something that's set on the host. That's something in Active Directory. So we need that to be set up. We don't need to do anything else to the host. We need to set those two files. OK, this is easy mode. What's the downfall? Well, the downfall is we don't really know what's running on the host. We don't know if we can trust all the software on the host. You could attach, theoretically, as the host admin, a kernel debugger, somehow see the host the VM while it's in memory. Tough, brutal. I don't want to do it, but you should be aware maybe that this could happen. But we think probably for enterprises who want to virtualize a domain controller or something like this is probably perfect. I mean, it's not too hard to set up. It's secure. It's a pain in the neck to get anything. You can't. You're restricted on what you can run on. You've got some great assurances here. But let's say you're a hoster now maybe, and you want to slap this on hard mode, and you want to really harden this down. You want to make sure that no host ever is peeking into no host admin is ever peeking into your VM data. Well, then maybe we do hard mode, which is TPM attestation. So we basically do the same thing, right? We restrict the amount of hosts that can run the shielded VM down to a limited set, and basically you enumerate all the public keys of the TPMs that you trust, but think about it, you just enumerate down to a set. And then we also say, but we also want to make sure these hosts are running software we trust. So for that, you need what we call a code integrity policy. And all a code integrity policy is basically says, hey, computer, you can run anything signed by Microsoft, Dell, and maybe your antivirus company, or something that you really trust. But all of a sudden now let's think that kernel debugger isn't signed by any of those sources. So all of a sudden you can't have the kernel debugger, you can't get into the host into the VM as a host admin, you get hardened security. I don't know why this is under benefits, but it is the thing to think about. This is harder to set up. There's a little more work on the attestation service side, because you have to configure it as to what software it likes, what host it can run. So there's more work there. But also you have TPM 2.0, which is barely starting to get in the market, so you may need new hardware. This is more complicated, but is more secure. And before we move on to what I think is the demo on the next slide, let's think about what we need, because the demo is going to use TPM attestation. What do we need to configure on the host in this case? Well, we need the 2 URLs, like we always will need. But also we need a CI policy. And all the CI policy is, it will restrict what software can run on the host. So let's move on here. Demo, let's go. So here we have a host in VMM that's just a regular host. It happens to have a TPM 2.0 chip on it. We look at the host. And in a second, we'll see the statuses are all green. It's a perfectly healthy host. It can run any VM in your environment. You love this host, right? But you want it to run shielded VMs now. So on the left-hand side, we can see the Host Guardian Service tab. And there's 2 checkboxes, which basically can let you set up to 3 things, like we've talked about. The top one's grayed out because VMM will only support 2 URLs for all the hosts, so you don't have a VM can run on some and not the other. And the code integrity policies are also global objects in VMM. Let's go set those up in settings now. And then we'll come back and guard the host. So we go to settings, and it's really not that bad for the Fabric admin to do this. Your secure the Guardian Service admin has already given you a couple URLs, so in a second we'll copy and paste them in here, probably from the same email he sent you. And we have the attestation server URL, and we have the key protection server URL. Now we just have to add that CI policy, because we're using CI TPM attestation. We have to restrict the software that runs on this host. So all we need is the friendly name, so we know what the heck we're dealing with. And we also need a path that points to that CI policy, because the host knows the path and gets the CI policy on itself. You don't have to manually put it. You just have to make sure it has access to the share. So it's an Intel machine, so we'll call it Intel CI policy. Pass in the path where the policy exists. Hit finish. This is the majority of the work that goes into setting up a guarded host. It's really not that bad. There's a lot behind it, but the work is not too bad. Now, we just want to make this host secure. So we go back to Fabric. Go up to our host that we loved, but now we want to run John's fancy shielded VMs. Hit Properties, Host Guardian Service. That first check mark sets the 2 URLs, so it's always there. And all it does is set those 2 URLs on the host. And the second checkbox here will apply a CI policy to the host, since we're using TPM attestation. And we have to select, actually, the Intel policy, so it's appropriate. Then we check this box, apply policy immediately. Applying a policy if there's essentially requires a restart. So we want to give you the option of maybe not bricking your host for 5 minutes you can apply it later during your restart cycle or something like that. And this goes through pretty fast. The rest of this demo is just waiting for a job to finish and then for a host to restart. And I even cut out most of the host restart. So what we're going to really see is that this job succeeds, because I recorded the demo. But the host will be guarded. It'll pass attestation, and we can run secure VMs on it. And I restart it manually here just to speed things up. So we're just going to give this 1 more minute so you kind of can see how you can tell it passes attestation. and we'll move on. So we're rebooting it so that the CI policy takes effect, so that it can pass attestation. The reboot's complete. And now when we right-click on the host and hit Properties, we can see that there's this new HGS client overall status. And it's green, which means the CI policy is working, it's passed attestation, and that the service that the client that works on the host is up and running. So you've got a guarded host now. You can run shielded VMs. We're going to move on from this now. There could be tons of questions because the underlying architecture is complicated. But we're going to switch gears and come back in Q&A to keep talking about this. We're going to talk about rolling upgrade. So what's the problem we're trying to solve here? We've heard from you guys for a while that upgrading clusters is hard. I think I've heard impossible a few times, and pain in the neck I've heard a lot. So we've tried to address this. And it's hard for a number of reasons today. It requires extra hardware. It requires weeks of effort. It requires manual work. It requires sometimes downtime. All this, I think this is probably the reason why there's so many of 2008 clusters, and no one can get off of it. So we want to make this easier for you, especially going from 2012 R2 to threshold. And so what's the solution? Well, thankfully, our Fabric team, and I believe there was a presentation on this yesterday as well, introduced this concept of mixed mode cluster. What's a mixed mode cluster? All it is a 2012 R2 cluster that actually has a threshold node in it. And the threshold node is running at kind of a legacy state. It's running as a 2012 R2 node, even though it has a threshold OS. So let's kind of see, how does this give us cluster upgrade without having to have $100,000 of extra hardware or a week of effort? Well, we can just gradually upgrade the cluster, right? We can evict a node, redeploy it. And this is a cluster anyway, so hopefully we can stand a node loss, but we can always bring another node in as well. Redeploy it with threshold or server 2016 or whatever we call it. Add it back to the cluster, and let's imagine we start repeating. And so what happens after we repeat on a 4-node cluster, this process 4 times with 4 2012 R2 nodes? Well, we have still a 2012 R2 cluster, but now it has all threshold nodes. And so with one API call, we change the functional level from 2012 R2 to threshold or server 16. And now we have, by only taking one node out at a time and putting it back in and keeping everything happy, we have a threshold cluster without a lot of the headache. So there's a couple questions. So what if I have VMs on this cluster? Well, the VMs now have a functional level as well, but it's decoupled from the cluster functional level, which basically means you don't have to worry about the VMs that were your 2012 R2 VMs. They'll continue to run fine. In fact, the Hyper-V team says, go ahead and leave these in legacy for as long as you want. It works no problem. If you want to update the VM's functional level, it's a right-click upgrade, right-click update, but it will have to restart. So whether or not you can afford a restart is totally up to you. You don't have to. We also will upgrade your file servers, which is actually more of a pain from what I've heard than your Hyper-V host because you have all the storage behind it. But the storage pools actually have a functional level as well that's, again, just like the VMs, decoupled from the functional level of the cluster. The beautiful thing about storage pools, though, is it doesn't require a restart. So in fact, in VMM, if you update the functional level of a file server, we'll automatically do the pools because there's no reason not to. If you chose not to, you just wouldn't get some threshold features. But there's no downtime. There's no reason not. It's just updates some metadata. So all that's platform stuff. You can do that with some time and some ISOs and some CD-ROMs and some networking and some coffee yourself. Why are we talking about VMM? How can VMM help you? Well, VMM can now, in Threshold, orchestrate this upgrade from start to finish. So ideally, this is 30 minutes of your time or less, and then you let VMM do all this heavy lifting of evict, redeploy, re-add. And how do we do it? Well, we've been able to deploy operating systems for a while now. And we call this our operating system deployment feature and process. And just out of curiosity, does anyone use OSD? Well, someone in the back does. I know. All right, we'll go with you 3. Well, maybe more of you will now. All right. So let's just look how OSD works real quick at like a high level. It starts with a physical computer profile. And think about this as like the bare minimum stuff you need to deploy a host. VHD of, in this case, threshold or 2012 R2, maybe the, what do we call it, the product key, some domain join stuff, really basic stuff about the host. Then we reach out to the host via its BMC, and we pull out in some extra information. We boot it up into WinPE. We can now discover all the disks, all the networks, and we let you customize it a little more and say, hey, I want this network, this NIC to be configured exactly this way, and build. And finally, after these 3 steps, we build a physical computer configuration. And a physical computer configuration object is a VMM object that basically lays out for VMM exactly how you want your machine configured and exactly what VMM is going to do to it. So it's your networking, it's your storage, and everything. From there, we deploy the computer. We get rid of the physical computer configuration object because we now have the host or file server object that you deployed, so we have all that information anyway. So let's imagine we have this workflow for OSD, especially these first 3 things, right? We really want the physical computer configuration because from there, it's a pretty straight shot to deploying the computer. How can we use this in upgrading our clusters? Well, we can really get rid of the 2 steps in red. We don't need to run deep discovery. We don't need to provide additional information because we already know everything from the host that's running in your environment anyway, so we just ask you for the same information you've already provided or you've already configured. So we still need the physical computer profile because we still need your threshold VHD, we still need your product key, we still need your domain stuff. We don't need really any more information than that. We'll let you customize if you need to, but we don't need much more. So you can skip the next 2 steps. We'll do some automatic stuff using the existing object in VMM, create your physical computer configuration, which is what you care about anyway, and then deploy your computer. So this is an animation. I've played a lot with animations. And we use an existing host to create a physical computer configuration. We save that to the side. Then we evict the node from the cluster, use this saved physical computer configuration, redeploy the node. So it's a threshold file server or host node with the exact same configuration it used to have because we created the configuration based off of what used to be there, and then we add it back in. So imagine a for loop that does it 4 times, and you have your upgraded cluster, and you've really only given us the VHD, some domain join stuff, product key, a few bits of information. So what's the requirements checklist? Since you guys don't use OSD, I'm going to go over this. You need a BMC on your host so that we can reach to it and boot it and control it out of band. It also needs to be set to PXE boot so that we can push down WinPE or VHD to it. And we need to have a WDS or PXE server under management, which none of these are very hard to do, but those are the requirements. I figured I'd let you know. And so let's see how this looks. There we go. So here we have a 3-node cluster in a dev build of VMM 2016 or whatever we call it. And we see this 3-node cluster is running Microsoft Windows Server 2012 R2 standard. So these are the operating systems on our 3 hosts inside the cluster. So we also have a PXE server under management, which is the other requirement, and I'm glad I'm showing you. So the PXE server is under management. So we're basically set to do this. The hosts are set to boot off the network. So we're looking good. And we'll go down here to the library because we need that physical computer profile. That's the one thing you have to create that we really need. So we'll create a new one, name it something friendly, like upgrade to 2016 or something like that. And in this case, this happens to be a Hyper-V host cluster. So we select Hyper-V host. We can do this with file servers as well, but we're going to demo it on hosts. So we click next. Specify the OS image, one of the most obvious and important parts of this if we're going to upgrade to threshold. And here we have a threshold Windows operating system. Hit next. Now, in normal OSD, you actually have to worry about this page because this is where you specify networking and storage and how it gets where we copy the VHD. We don't have to worry about that now. We already can automatically detect this. We know about the host without you telling us this. So we can basically skip the network config and your disk can partition all this information. So we skip it. We still need some stuff like your domain credentials and your product key. And again, we don't need anything with the virtual machine pass because you've already set this on your host. So it's kind of, you don't have to put this in either. So in a second, I'll click next. We'll see a summary. Unless I didn't pause it. OK, summary, finish. The job runs, and we have this physical computer profile, which is really the one prerequisite to this entire workflow. So this is pretty important. All right. So now we'll go back to our fabric, and let's check out one of the nodes in this cluster we're going to upgrade, just so we have a feeling of the type of stuff VMM is going to do for us, and I can prove that it kind of works. So we right-click on a node in the cluster, properties, or double-click. We need the BMC addresses of these nodes, which are not in yet, because we didn't deploy these nodes via VMM, so we don't know this information. But we've taken this into account, so if you haven't deployed your nodes using OSD, which none of you have, you can still use this. You just have to type in 3 IP addresses in this case. So BMC information we'll need, and now we'll look a little bit at our networking. We can see we have 2 physical NICs, here and here. And they are attached to a logical switch. And off that logical switch, we have 2 VNICs. The first one, I think, is DHCP. Yep, DHCP. And the second one's going to have static IPv4 and IPv6. So kind of a complicated NIC to set up attached to it. And additionally, we have a third NIC on this host, which is just configured with a static IPv4 address. Yep, there we go. We aren't going to look at storage or what partition we're booting off, because VMM has to do a little magic to make this work, and it doesn't exactly, all the GUIDs don't always match up, but everything persists from storage as well. So let's upgrade the cluster. We right-click the cluster over here on the left, and we see 2 options. One's upgrade cluster, and one's update version. If you remember when we had to update the cluster functional level, that's what upgrade version is. The naming isn't finished on that. But it's not applicable now, because we have nothing to upgrade. We're running a regular 2012 R2 cluster, so let's just upgrade the cluster. And we select the nodes we want to upgrade. In this case, we want to redeploy all of them and go through the entire workflow. So we select all. And then we select the physical computer profile we made earlier with the Windows 2016 VHD. And we can see that the nodes in the cluster are running 2012 R2, and the operating system on the VHD is Technical Preview or 2016. So we have some validation that what we're doing makes sense. We hit next. We're skipping cluster validation, too. We will run it if you check the box. And now we have to talk about your BMCs that none of you have used before. So we need to specify a BMC run as account and the protocol we use to talk to the BMCs. In our case, we're using like an internal protocol to make this easier, but you'll use IPMI or SMASH, which are pretty industry standards. So this is the physical computer configurations that have been generated for you, so you haven't had to enter any extra information. And with a little quick browsing of them, we can see that your network settings are the same as what you would expect. We've already got the MAC addresses in there. We know that 2 of them are connected to a logical switch. We need to know one has a static IP, et cetera. So the one piece of information we do have to enter, because we have to talk to this machine out of band, is the BMC IP addresses. So really the only other information you've had to add is the 3 IP addresses for these 3 machines, which isn't too bad. You've created a host profile and you've entered 3 IPs. This doesn't take too long to do. So we'll go ahead and enter these. You'll notice the serial number and manufacturer unknown. This we read directly from the BMC, and since we've never reached out, we don't know it, but it's not that important to this process. All the important stuff is there. Like your next. OK. So we'll click Next. And we'll see the summary of the job we're about to kick off. We're redeploying 3 computers. We have the host profile. We're skipping cluster validation. As anything in VMM, I'll show you the script for this, because you can run this all through PowerShell as well. So you can do plenty of customization on your own. But as you can see, this is a pretty massive job and a pretty massive script, identifying all your networks, collecting them from the host, building configurations, So I'm not going to spend too much time. I'll show it to you, but we aren't going to walk through this. So let's close this and hit finish. Boom, the job started. And it's hard to see, but in the very top left corner it says host 3. And we'll see in a second that goes to host in parentheses 2 because the first host will get evicted from the cluster. So we remove it from the, yep, now it's 2. We've also we're removing it from management as well because we have to totally redeploy it. So VMM is going to forget in management about this host. And we've created this add host to cluster workflow. So we're deploying the host directly from bare metal to the cluster. And if we give it just a second here, check the time, perfect. This will complete. Great, here we are. So now let's look at our cluster. We still have 3 nodes. One's running Technical Preview 2, and the other 2 are running R2. And I'll show you just a couple properties in PowerShell that we have now for mixed mode clusters. The first one is functional mode. So we get the cluster and get the functional mode. And aptly named, it's in mixed versions because some are 2012 R2, some are in threshold, so it makes sense, mixed mode cluster. And we'll also show you the functional level, which is 8, which means it's still running as a 2012 R2 cluster. So by this time, we should be getting pretty close to the second node redeploying. Yep, here it comes, adding node to cluster. Give it a second. Boom, it's back in. So now we have 2 in technical preview, 1 still to go. And in a second here, we'll look at, while the third one deploys, we'll look at exactly what's been persisted. So you can believe me when I say your network settings have come back. You don't have to figure that all out again. So here we go. Third one's going. It should be kicked out of the cluster here in a second. Yep. OK, so we only have 2 nodes in there. The third one's redeploying. So let's look at the properties on this node. First, we have now persisted the BMC information, so you never have to enter it again. Remember, we didn't know about this before, but during deployment, we're going to keep persisting this in. So if you need to redeploy it later, we have it now. You don't have to remember it. And now let's look at our NICs. We still have 2 physical NICs connected to a logical switch. They actually have the same name, too, which is something we couldn't do for a while. So we persisted name through. And we have 2 virtual NICs built off this, one with DHCP, the other with static IPv4 and IPv6. And we still have the third physical NIC here with the static IPv4. And with that, I believe the third node's done. Perfect. So now we have all 3 nodes in a 2012 R2 cluster running threshold. We only have one thing left to do, and that's to update the cluster functional level, which now when we go to the left, we will see is unchecked, so we can just update it, and we're done. Update version. This is a point of no return. Once the version's updated, this will forever be a threshold cluster. We could theoretically back out all our changes now and evict and put in R2 nodes, but now it's done. You've upgraded your cluster in a bit of time, but very little effort, ideally, from you. Secondly, since it is time, networking things could screw up this process. The whole job is very restartable, so if you have a network communication issue and somehow the job fails, you can restart it from where it last off. We don't want to leave you stranded with a job that you can never come back from. So we're about to finish up here so we can have some questions. I just want to give you a grab bag about what else we're doing in Threshold so you have some idea. We've done quite a bit of work with operating system deployment motivated by what you just saw with the cluster upgrade. For example, now you can name NICs through deployment, so you don't have to have weirdly named NICs. You don't know what they are when the host gets deployed. We also allow you to run generic scripts, so after deployment finishes, you can, I don't know, open up RDP or install a firewall or or install an antivirus, whatever you need to do that's custom that we wouldn't know about. And we can deploy directly from a bare metal node to the cluster. NanoServer, I don't know if any of you have heard of NanoServer. Did you go to those? Couple more, okay. So a few more. We will support NanoServer. We don't have it quite yet, but it's coming soon. And VMware support's coming with 5.5 and 6.0. They may come, as John said, even in URs, but certainly in the threshold time frame, we're looking at supporting both of those. So with that, there's a little bit about securing your fabric, a little bit about hopefully making your life easier and allowing you to upgrade in the future, and a little snippet of some other stuff we're doing. Let's have some questions and answers and get out of here, huh? And as we do the questions and answers, those surveys, thank you guys so much. Whoever you're handing to in the back, we'll figure it out. But we really appreciate it. Do it.
What's the performance impact of running a secure host? Is there any performance impact?
Of a host or a VM? A guarded host or a shielded VM?
Guarded host with a shielded VM running on it. Otherwise, why wouldn't I just do that with all of them?
There is definitely going to be a performance hit, particularly we're encrypting and decrypting all over the place, and that's fairly processor-intensive process. We're still profiling that. I don't know if we have hard numbers yet. For those level of details, you probably want to go back and watch the video that came.
Dean
did
yesterday. There's a whole
Yeah.
harden the fabric assurance deck.
Okay, so it sounds like that'd be a decent configuration. If I want to run a host like in my DMZ, for example, right? It's got some more surface area to it.
Sure.
I want to run a couple of Hyper-Vs out there, but if something did get in to that infrastructure,
Yeah, you'd have to use TPM, I think, attestation, which is a little more complicated because you don't have a domain in the DMZ, right?
Right.
it's a separate domain, yeah. But
Okay, more configuration, but yeah, your
But
VMs
if
are
the
more at
DMZ
risk.
if the AD is in the DMZ as well, then that's
Yeah.
also a security risk. So yeah, I think that would be a good configuration for you. But again, like you said, there is going to be a definite performance hit for running these. The idea is you're probably only going to want to run HBI, high business impact workloads within those VMs. So yeah. And as the months progress here in the next, over the rest of the summer and through the fall, we'll be able to publish those numbers on what the exact performance impact is going to be.
excellent, thank you.
Sure.
Yeah, thank you.
So is there anything that's different for backing up and restore procedures for those guarded hosts?
For a guarded host, not really. For a shielded VM, backup would be.
For shielded VM, there's going to be it's going to be quite a bit more complicated because, particularly if you're going across different fabrics that are going to have a different host guardian service or
Yeah, host guardian service,
host
you got
guardian
it.
service. Yeah.
There may be some synchronization stuff.
For the host, not that much, but then for the guarded VM, there might be a ton of extra steps to do.
That's right. Well, it shouldn't be too bad. A big part of that's going to be specifying the correct guardians in that key protector list that we were discussing earlier. So that's probably where most of your work's going to happen. And we haven't looked at that too much. There's probably some orchestration we can do to help out with that as well. Yeah.
And then is there any concern about running two of those, like a clone scenario, it's at the same environment? Does it like conflict and say, oh, there's two of these same exact systems that should be running on the exact same host?
In that sense, it shouldn't. I don't believe that should be any different than running a standard VM today. Yeah.
Because, for example, like doing a snapshot, making a clone of that,
Sure.
and then trying something in
That's
the
right.
environment, but it's the same exact server that's currently running in that protected environment. I didn't know if there's a check to make sure that there's not two of them running at the same time. See what I'm saying?
I don't think there's a check with
No.
replica today, though. If
No.
you accidentally run them at the same time, you're host. Right.
So I'm asking if there was some other magic that you guys are doing behind the scenes for the protected VMs and all that.
Yeah, I don't believe that there should be an issue
Not for
with
that particular scenario, I don't think. Yeah, if you fire them both up, they kind of go off in their own separate directions.
Yeah. Yeah. Sure. Thanks for coming.
Yes. Yes,
I have no
I
idea.
almost definitely believe so. Remember, for the workload, it's kind of NanoServer independent. But for the guarded host, it's a couple properties in Hyper-V, which I would think, yes, Yeah, I could get total confirmation on that, but yes, I would be shocked if it couldn't be.
That's a warm and fuzzy.
What's the minimum SCVMM version and Hyper-V version they need to run in order to run Shield VM?
It'll be threshold.
It'll be 2016 or threshold. Yep. This is brand new. Thanks.
Thanks,
Take care,
everyone.
everyone.